8,000 salmon, one dead river, and a bunch of Canadian scientists who thought they had everything figured out. Spoiler alert, they didn't. What happened next wasn't just unexpected. It rewrote the rule book on river ecosystems and made biologists question everything they thought they knew about nature's comeback tours. Keep watching because this gets weird. The year was 2003, and the Elwha River in Washington State. Wait, hold on. Washington State. I thought this was about Canada about that. The river's in the US, but we'll get to the Canadian connection in a minute. Trust me, it matters. The Elwha had been dead for nearly a century. Not metaphorically dead, actually dead. Two massive dams choked it off in 1910 and 1927, turning what used to be one of the most productive salmon rivers on the west coast into a glorified irrigation ditch. Before the dams, the Elwha was legendary. Over 400,000 salmon would fight their way upstream every year. Chinook, coo, sockeye, pink, and chum. All 5 Pacific salmon species. Some of these Chinook were absolute units, weighing over 100 pounds. That's heavier than most people. These fish were so massive that indigenous peoples called them Tai, meaning chief. But after the dams went up, the salmon runs collapsed. By the 1990s, fewer than 3,000 fish returned annually, and they couldn't get past the first dam anyway. The upper 70 miles of river became a salmon graveyard. No spawning, no nutrients, no life. Here's where it gets interesting. In 2011, the US government decided to do something almost unprecedented. They started removing both dams. Not retrofitting them with fish ladders. Not building fancy bypass systems. Full removal. Blow them up and let the river run free. The largest dam removal project in history. But there was a problem. A big one. The river had been dead for 90 years. 3 generations of salmon had never seen the upper reaches. The genetic memory was gone. Even if you remove the dams, how do you teach fish to come home to a place their great-great-great-grandparents forgot existed? It's like asking you to navigate to your ancestors' village from the 1800s with no map, no GPS, just vibes. This is where Canada enters the chat. And this is where things get properly weird. Canadian fishery scientists had been watching the Elwha situation closely because they had their own problems. British Columbia's rivers were facing similar issues. DMs overfishing, habitat destruction, the whole doom playlist. They'd been relocating salmon to rivers the fish had never seen before, essentially forcing them to create new home streams. Kind of. The Canadian approach was based on a controversial idea. For decades, biologists believed salmon imprinting was fixed. Baby salmon learn the chemical signature of their birth stream, and they follow that signature home years later when it's time to spawn. That's the gospel. Except the Canadians were finding out it wasn't quite that simple. Salmon have backup navigation systems, magnetic field detection, sun compass orientation, olfactory learning that can happen in stages, not just at birth. They're basically organic GPS units with multiple redundancy systems. So, when the Elwha Dam started coming down in 2011, a group of American and Canadian researchers decided to test something bonkers. They would take salmon from other river systems, bring them to the Elwha, and see if they could bootstrap a new population, force-feed evolution, basically speed-run ecosystem recovery. In the spring of 2012, they released 8,000 juvenile Chinook salmon into the upper Elwha River. These fish had never seen this river before. Their parents hadn't either. The fish came from hatcheries supplied by Canadian and Pacific Northwest stocks, carefully selected for genetic diversity. The scientists expected maybe a 1% return rate. That's typical for salmon restoration projects. You release 10,000 fish, you get 100 back. Nature's brutal like that. They were wrong. Very wrong. The first returning adult showed up in 2014, right on schedule. Salmon have precise life cycles, meaning they'd spent 1 year in fresh water, 2 years in the ocean, and now they were coming home. Except home was a place they'd never been. And they came back by the thousands. By 2015, over 3,000 adult salmon had returned to the upper Elwha. That's a 37.5% return rate. For context, that's basically impossible. Modern hatchery programs celebrate 5% returns. Wild populations average 2 to 3%. These fish were returning at rates that hadn't been seen since the 19th century. Biologists started scrambling. What the hell was happening? Here's where it gets absolutely wild. The salmon weren't just returning. They were thriving. And they were changing the river in ways nobody predicted. See, when a salmon dies after spawning and they all die, that's how Pacific salmon work. Their bodies become fertilizer. Each salmon carcass is a nutrient bomb packed with nitrogen, phosphorus, and carbon from the ocean. It's called a salmon subsidy, and it's one of nature's most efficient resource transfer systems. But the Elwha hadn't seen this subsidy in 90 years. The forest surrounding the river was starving. Trees near salmon streams grow bigger and faster than trees away from them. They've measured this. Some riverside trees get up to 25% of their nitrogen from salmon. When you cut off the salmon, you slowly starve the forest. The Elwha's riparian zone was in rough shape. Smaller trees, less diversity, fewer birds, fewer everything. And then those salmon had babies. And then those babies grew up and came home. And suddenly, thousands upon thousands of salmon were dying along the river banks every fall. And the forest started waking up. Within 3 years, nitrogen signatures in riverside vegetation changed. Isotope analysis showed marine-derived nitrogen appearing in plants that hadn't seen it since before World War I. Insects exploded in diversity and numbers. Then came the birds, bald eagles, ravens, gulls, dippers, species that hadn't been seen in those numbers for a century. Then mammals, black bears, river otters, mink, raccoons, all feeding on the salmon bonanza. But wait, there's more. And this is the part that made scientists lose their minds. The salmon started engineering the river. The Elwha had been simplified by the dams. No large woody debris, no complex channel structure, just a straight shot of fast water. Boring. Salmon need complexity. They need pools, riffles, gravel beds, side channels, all the stuff that makes a river look messy and chaotic. That's where baby salmon hide from predators and find food. So, the returning salmon did something incredible. They started building it themselves. When thousands of salmon spawn, they dig thousands of nests called redds. Each female digs out a depression in the gravel, lays her eggs, and then digs again upstream, which covers the first nest with gravel. It's laborious work. It's also geomorphic engineering. All that digging moves thousands of tons of sediment. It creates pools and riffles. It sorts gravel by size. It breaks up compacted stream beds. The 2012 salmon release didn't just bring back fish. It brought back a construction crew. By 2016, channel complexity had increased by 40%. New side channels appeared. Gravel bars shifted. The river became more dynamic, more alive, and that complexity created better habitat, which supported more salmon, which created more complexity. A positive feedback loop. The thing that made this whole experiment terrifying and exciting in equal measure, the salmon that returned weren't just any salmon. They were different. Genetically distinct from the source populations. Evolution in real time. Researchers started analyzing tissue samples. The returning fish had genetic markers suggesting rapid adaptation. They were larger than expected. They had different run timing than their parents. Some were spawning earlier, some later, spreading out the nutrient delivery over a longer season. The river was selecting for traits that worked in this specific ecosystem, and the salmon were responding in just a few generations. We're talking about evolution on human time scales. This isn't finches on the Galapagos taking millions of years. This is wholesale ecosystem resurrection happening fast enough that the scientists who started it could watch it complete within their own careers. Now, you might be thinking, okay, great. Canada helped release some fish and it worked. Why does that matter? What's the lesson here? Because nobody expected it to work this well or this fast. The conventional wisdom was that ecosystems take centuries to recover from major disturbances. That salmon populations need decades of careful management. That you can't just dump fish in a river and expect nature to sort itself out. Except that's exactly what happened, and it's changing how we think about restoration ecology. The Canadian scientists who helped design this experiment had been criticized for years. Their methods were considered reckless. Genetic purists argued that moving salmon between rivers would dilute local adaptations, create weak populations, and ultimately fail. The critics said, you can't shortcut evolution. You can't force ecosystem recovery. Nature doesn't work that way. Except it did work. The Elwes salmon proved that ecosystems are more resilient, more adaptable, and more willing to bounce back than we gave them credit for. They also proved that our understanding of salmon homing, that sacred, immutable instinct to return to their birthplace, was incomplete. They can adapt to new rivers. They're not locked into rigid patterns. They're flexible, dynamic, and opportunistic. This has massive implications. There are over 1,000 dams in the Pacific Northwest alone. Many of them are old, outdated, and blocking salmon habitat. For years, the assumption was that removing these dams would be pointless because the salmon were already gone. You just end up with an empty river. The LWAD experiment proved that wrong. Give them access, give them a chance, and salmon will come back fast. But there's a darker side to this story, one that the feel-good headlines don't always cover. The speed of this recovery created problems. All those returning salmon died in the river as they're supposed to. But thousands of rotting fish release a lot of nutrients. Maybe too many nutrients. By 2017, some stretches of the river were experiencing algae blooms. Dissolved oxygen levels were dropping. The ecosystem was adjusting to the sudden abundance. But it was a messy, chaotic adjustment. Nature doesn't do smooth transitions. It lurches from one state to another, and sometimes things break along the way. There were also conflicts. Commercial and recreational fishermen started complaining that too many salmon were being diverted to restoration rivers. Hatchery managers worried that mixing wild and hatchery fish would create genetic problems down the line. Indigenous communities who had been advocating for salmon restoration for generations were mostly supportive but also wary. They'd seen too many government promises fall apart. They wanted long-term commitments, not just a one-time release and a press conference. And then there's climate change. The elephant in every environmental story. The Elwes salmon are returning to a river in a world that's 1.5 degrees warmer than when their ancestors last swam there. Ocean conditions are changing. Heat waves are stressing fish. A natural climate pattern that affects salmon survival is shifting in ways we don't fully understand. These salmon are incredibly resilient, but resilience has limits. As of 2024, the Elwes continues to surprise everyone. Salmon populations are stable and growing. The ecosystem is maturing. Researchers are finding salmon in tributaries that haven't seen them in over a century. The forest is greener. The river is louder. It's not perfect. And it's not finished, but it's working. A dead river is alive again. And it all started with 8,000 fish and a handful of scientists willing to try something that everybody said wouldn't work. They released those salmon not knowing what would happen. They just knew the river was dead and doing nothing wasn't an option. So, they did something and the river responded. That's the real lesson here. Ecosystems want to heal. They're primed for it. Forests recover from fires. Reefs rebuild after storms. Rivers come back to life when you give them a chance. We just have to get out of the way, blow up a couple of dams, and release 8,000 salmon. Nobody expected it to work this well, but nature doesn't care about our expectations. It just does its thing.